Chapter number 4, testing techniques. In this chapter, we will be discussing about categories of test techniques, black box test techniques, white box test techniques, and experience-based test techniques. Here I would like to take a deviation, basically. Teaching with the help of PPTs would be too abstract. Let's go to one of the books that I had written some time back. Here, if you see testing techniques, right? These are all static testing techniques, right? Basically, informal reviews, what we discussed some time back, technical reviews where subject matter experts involved and generally reviewers will be peers of the authors. Walkthroughs can be formal or informal. Inspection, the most formal way of static testing, where the review outcomes are documented and review happens in a formal way. Scribes are involved and things like that. From chapter 3, you can recollect that. These informal reviews, technical reviews, walkthroughs, and inspections are form of static testings. And in addition to that, we take the code and trace the control flow, how the control is flowing from one line to another line, and then so that kind of analysis, if it is done, that is also a form of static testing. And if you do data flow analysis, how the data is flowing, say for example, from one class to another class. That is a form of static testing again. And if you are making use of any tools like lean tools, etc., for analysis of static analysis, that is also a form of static testing. Generally, this is classified. All this static testing technique is generally considered as gray box testing. Okay, basically it's a hybrid of black box and white box. Now, next thing is, once you looked at static testing, let's look at dynamic testing. Dynamic testing, actually, here you actually run the software, right? In static testing, you don't run the software. In dynamic testing, you actually run the software during testing. So again, it can be structure based, specification based, or experience based. So here in this book, actually, generally this experience based and structure based, these both are white box testing. I should have used white color for this leg and this leg, but color coding scheme is not followed properly in the diagram. So basically, the structure-based testing and experience-based testing is white box testing, because you have visibility of the code, or you take a peek of the code while testing. And then, specification-based testing is black box. So I repeat, this is white, okay, and this is black. So in black box testing, in the specification, you would have known well in advance how the system is supposed to behave, and according to specification, if it is working or not, you test as a part of a testing. So that is specification based testing. So in specification based testing can be again it can be equivalence partitioning, boundary value, decision table based, state transition based, or use case based. Now let's touch each one of them one by one to understand what do we mean by these testing categories or testing techniques. So now if you come right, yeah, that's what we are telling. Static testing where no test cases are executed. Generally done before test cases are executed on a software. So static testing is done before dynamic testing. Specification based is black box. Structure based is white box, and experience based is also considered as white box. Okay. It is also considered as white box. Now let's look at each one of them, what we mean by specification based or black box based testing techniques. It can be either equivalence partitioning or boundary value. So in equivalence partitioning, what we do is generally we will have something called input domain, right? The software accepts a certain set of certain range of inputs, and it produces certain range of outputs. So this input domain, right, the kind of inputs that you supply to the software are divided into partitions. And or output domain is divided into partitions. Let's say you have a banking software which is supposed to give 3% interest rates for deposits up to $100 and 5% for deposit greater than 100 but less than 1000, 7% deposit for amount in excess of 1000, right? Here you clearly see that input domain is divided into $100 deposit, $1000 deposits, and more than $1000 deposit, right? So here you need to have test case for each of these scenarios. So generally you will deposit lesser than 100, more than 100, less than 1000, more than 1000, and so forth, right? So you ensure that you cover a range of inputs to be supplied to the software, and you check in each of those cases what is the interest rate being used for calculation. That is partitioning testing technique. And then in boundary value, what we do is exactly at the boundary, right? You could choose values like 99.9, 100.1, 999.9, and 1000.1, right? So you choose the values at the boundaries of these partitions. So that is a boundary value analysis. Okay, and then let's come to decision table based testing. In decision based table testing, what we do is, let's say there is a credit card discount policy, and the policy goes like this: for new customers 15% discount, existing customers with loyalty card 10% discount, and if the customer has coupon, then 20% discount. Okay, so this is let's say the management has decided, let's say, this policy for a credit card. Then clearly you see there are three variables, right? So and then you need to decide design test cases for these three variables in mind. So they can take values true or false, right? True or false. So it is 2:3. That is 8 test cases. Let's see here. 4 and 4, 8, right? 8 set of test cases you need to come up with, and then each one of those variables, right? New customer, loyalty card, and coupon can take value true or false, right? 2 to the power of 3, 8. So you tabulate the values for each of those cases, right? It can be TTT, meaning all true, TTF, okay, TFF, TFT, FTT, and things like that. People who would have designed a kind of map can very easily come up with this kind of table. So same concept here. And then what you notice is certain combinations are not possible, right? A customer cannot be new and loyal at the same time, right? Loyalty card is given to somebody who has been a customer for a very long period. So this T and T is not possible. So you need to check whether this thing is happening or not properly, and then both again TT not possible. And for other cases, right, where let's say a new customer and basically new customer and coupon simultaneously, if he is holding, and then 15% discount is applicable, and things like that. And if coupon is there and coupon is there and customer is not new or loyal, then 20% discount. So these calculations are happening as per these decision tables or not, you need to check. Next is state transition diagram based testing. ATM pin, ATM machine is a very good example for this. Let's say you start here, okay, you wait for machine to ask for a pin. In the first attempt, you enter correct pin, and then access to account is allowed. Let's say you enter pin incorrectly, then the second attempt happens. In the third attempt also, if you don't enter the pin correctly, your card is ejected, right? So here, the software is transitioning from state to state, right? This first attempt, second attempt, and third attempts are different states. So, in first attempt, if even if pin is not okay, you are transitioning to second state. But in third attempt, if pin is not okay, like the card gets ejected. So this is state transition based. And in use cases, what you do is you beforehand understand in what all use cases the software is supposed to work, and you design use cases accordingly. Okay, now let's move to next thing, that is here. If you see, we covered specification based. In specification based, equivalence, boundary value, decision, state transition, and use case. Now let's concentrate on structure based testing. Let's concentrate on structure based testing. Yeah, in structure based testing, check what is the statement coverage, what is a decision coverage, and what is a branch coverage, right? What is a branch coverage and what is a condition coverage, right? Also you could check multiple conditions. If multiple conditions are involved, you check what is the value for each of those cases. Let's say you have a product code, and let's say 10,000 lines of codes are there in that product software. Then you run the test cases, and when you run the test cases, if 8,000 lines get tested, right? If 8,000 statements or lines get tested, then statement coverage is 80%, right? 80%. So 80 lines out of 100 are getting tested as a part of testing. Next is decision coverage. Right, the control flows in the software depending upon the decisions, right? If A is less than 10, let's say if there's a code like that, and then I'm talking about C, C++ and Java code, JavaScript code. So generally, if A is less than 10, you fall into the curly braces of that particular condition. And if it is not, you trace some other path. So you need to make sure, maximum legs of the decisions are getting covered. If all the decisions are getting exercised for both the cases are true and false, then the decision coverage will be 100%, right? And then decision coverage and then branch coverage. In addition to these three, we also have called multiple condition coverage, right? So let's say if there are two, you will have A less than 10 and A less than let's say A is greater than 15, right? A is less than less than 10, but A is greater than 5. Let's say there's a condition like that. Then you need to make sure both the conditions are exercised. And generally it becomes more important when there are OR conditions. Right, like in software, generally when there are OR conditions, when the first condition is evaluated to true, we don't even evaluate second, third, and so forth conditions. So but for safety critical softwares, you need to make sure all the conditions of ORs are also covered. So that is a multiple condition. And then we have something called experience based testing technique. So here the experience of the tester is used as asset for testing. So error guessing and exploratory testings are examples of experience-based testing. So generally the tester would have a hunch or intuition of guessing errors, right? If I test it like this, the software will software defects get covered. So that kind of intuition or error guessing capabilities of the testers is used in experience based testing. And in exploratory testing, right, well in advance you will not know the whole software functionality. You go on you go on developing test cases, and while developing test cases you understand the system. So that's exploratory testing. So let me quickly recap. Two main branches of software testings are static testing and dynamic testing. Static testing is gray in nature, okay, and dynamic testing certain part is black, right, and certain part is white. So this you need to remember. So in dynamic testing, it can be structure based, specification based, or experience based. If it is specification based, again, it can be like equivalence partition based, boundary value based, decision table based, or state transition based, or use case based. If it is white box testing, it can be structure based testing, can be statement coverage checking, decision coverage checking, and condition coverage checking testing technique. And experience based, right, the experience of the tester is used as a set. Generally this is considered as a white box approach. So the tester makes the error guessing and come up with the test cases, and the tester may also employ exploratory testing approach, where the system is understood more better while designing the test cases. So let's revisit this PPT. We have covered categories of test techniques, black box test techniques, white box test techniques, and experience-based test techniques. Now let's check, okay, whether the important keywords recommended by ISTQB are covered or not. Okay. Black box test technique we have covered. Like we visualize the software as a black box. We don't look into the code. We don't take a peek of the code, and specification will be known well in advance for the software, how it is supposed to behave for certain combinations of input. And then next is boundary value analysis. Whenever you partition the input domain or output domain, you choose values on the either side of the boundary, that's boundary value. Checklist based testing is formal in nature, so you will be having a checklist how to approach towards testing. Coverage, again a broader term, it can be requirement coverage, code coverage, or function coverage. And then decision coverage is ensuring every decision is exhausted. Decision table testing, like we discussed about credit card example, right? So that is the one. And error guessing, error guessing experience of the tester is a set, and certain guesses are made for capturing the errors. Equivalence partitioning, input domain or output domain is partitioned into partitions. Experience-based testing techniques we have covered. Exploratory testing, we understand the system on the go. Like we will not be knowing the whole system. We come up with the test cases in exploratory manner. And state transition testing, ATM pin example, ATM card example we have covered. Statement coverage is how many statements are getting covered. Test techniques, right? Test techniques basically static and dynamic, right? And in dynamic, it can be structure based, experience based, or specification based, right? And in use case testing, you come up with the test cases for each of the use cases. White box testing techniques is a standard testing practice where you make use of code coverage tools, right? Like Clover, Istanbul, or any other tool to gather the white box matrices, white box testing matrices. So that was in a sense chapter 4. So we concluded chapter 4. Let's meet in next chapter. Thank you.